Hello, in this video we would like to introduce our company, AcroEdge Co Limited. In this video, we will tell you who we are and what we are doing here. To jump right in, AcroEdge is a developer, manufacturer, and vendor for processing equipment, analytical instruments, and precision devices for various material research and engineering purposes. In particular, we specialize in devices for the characterization of thermoset, polymer, curing resin, and related chemical products. Essentially, these are stick plastic that require UV radiation or heat to manufacture. For example, one of our flagship products, the Curio, is a curing reaction monitor that can rapidly and consistently measure the curing degree of UV curing and other thermoset resin. This flagship application across a wide range of industries that utilize polymer products, adhesive, resin, and bonding agents. This includes electronic device components, various plastic, automobile parts, and precision components in various applications. Imagine a typical process line equipped with an irradiator where components of film are formed from a resin or bond by adhesive. This example here is that for smartphone, without a monitoring system, critical parts can receive differing amount of curing treatment. This may result in different mechanical property value and inconsistent performance marker across various samples. In the worst case, you can even get overcurve or undercurve product. With a Curio, however, quality and process control can be rapidly evaluated for each product on the spot as the conveyor belt moves along. By establishing a control range for acceptable product curing treatment, the Curio can immediately report if a product is good or not good. This saves time, material costs, and manufacturing costs, and boosts both production capacity, quality control, and efficiency. With this and the modular design of the Curios, customization and client-specified system are possible. This example here shows how the system is applied for film or plastic sheets. In some plant, two films are bound together by the adhesive resin, and parameters like the exposure time, amount of resin are very critical. If more detailed measurements are needed, the device can also be used to create 3D intensity map of the entire surface area. In the manufacturing of optical discs such as DVD or Blu-ray, a protective layer of resin is spin-coated onto the disc and irradiated with UV light to cure it. This example shows the uniformity of the spin-coated resin. Here, you can determine that the treatment is uniform for the most part, where the middle area is likely green to yellow. However, as the sensor approaches the edge, this tells us that the amount of resin on the edge is either thicker than the rest or has been irradiated insufficiently. The application of our technology are everywhere, and there is always continuous research to develop better model and client-specific device customization. This aside, we have a good catalog of analytical instruments and devices. Some are shown here. For example, AV10, a viscometer. Crisis, a surface modification sensor, can track change in surface property like roughness and surface energy that result from the manufacturing or treatment process. Stencil, a tensile tester series, is designed for small geometry from fiber to film and can be customized for measurement in various environments. UV is our series of UV LED module for curing system. And crossed here is another proud development of AcroEdge, a system that measures the shrinkage and stress undergone by resin during the curing process. We hold both the patent to this as well as the Japanese Industrial Standard or JIS and an iOS International Standard for measuring curing shrinkage and stress. Clients for this are typically any company that require precise knowledge about the shrinkage and stress that happen in your liquid resin as it cuts into the solid component. In this slide, I would like to show you our stencil. This is an ultra small and compact tensile testing machine. It can measure the static strength of polymers such as film, rubber, and fiber. It can be customized and modular for client-specific needs and purpose. Here is an example of using stencil to test single fiber. And here is a compact type of stencil tester. And this is a fluid environment type of stencil tester. This is an example of a two-exit type of stencil tester. Generally speaking then, we serve our system and solution are customized to meet client needs. How does this work? How do our solution add value to our client operations? Let me walk you through an example using our Curio UV fluorescent monitoring device. Aside from this, AcroEdge has also been assertive in research and development of new products and devices depending on market trend and the request of our client company. An example, for quite a while now, AcroEdge has been undergoing joint R&D with Kyoto University for the development of a new system that can measure and analyze nanoparticles. To give a brief explanation, nanoparticles are now widely used in multiple fields. Zinc oxide and titanium oxide are both very popular materials in the semiconductor and cosmetic industry. The average size of the particle used inevitably affect the final product property and performance. Moreover, typical technology that exists for the determination of nanoparticle size distribution and aggregation characteristics have limitations. So, a device that can do this quickly, accurately, and conveniently is in high demand. In the upper right photo is a prototype design we've been working on, wherein the working principle of our technique consideration of the effect of physics on the nanoscale plus or typical processing parameter in patents that utilize nanoparticles. This is a good challenge. Beyond this, other R&D projects also exist in collaboration with other partner companies and universities, as you will see later. For now, I think this is a sufficient introduction to the kind of work we do. For anyone who wants to know more about our technology, see some of the work, or learn how we can help you, we are based in Hirakata City, Osaka, Japan. The company has been in operation since 1986 and has built its network of client, partner, and collaboration over the years. As you have seen, our technologies serve the support other manufacturers, and our success can be seen in our distinguished track record. We maintain great relations with a lot of large Japanese and foreign companies, as well as research institutes and universities. This list is actually incomplete since we have some ongoing projects with institutes and companies both in and out of Japan. Before moving on, I will just share some action shots from the company. Here are a few photos showing AcroEdge at the International Material Technology Expo in Tokyo, one in 2018 and one in 2019. Next, here are two photos showing part of the lab environment. At AcroEdge, we prepare for progressive move, both in advertising and exposing the company to the international market, and in globalizing by hiring foreign talent. This shows AcroEdge forward thinking and that it has been making deliberate effort to become a global company. And now for a big next step, AcroEdge wants to enter the Asian market. For one thing, the Asian region is rising. Current industry trends show the increasing relocation of various industries to the Southeast Asian nations. Among our clients, some Korean and Chinese makers have begun plans to relocate factories to Thailand or Vietnam. Some already have base in area. Moreover, Thailand has strong auto parts and material manufacturing industry, making it the best choice for AcroEdge in terms of potential market. Given this, and the opportunity presented by Toshiba Corporation with Chiang Mai University and the Thailand Northern Side Park, AcroEdge embraced the challenge of expanding to the Asian region. Thank you for your kind attention.